Hey, geometry friends, welcome to Chapter 8, first lesson, 8.1, Triangle Similarity. And this is going to be a great chapter. We're going to learn a lot of important trigonometric ideas and principles. But first, we're going to return back to triangle similarity and learn some cool stuff there. So let's jump right in. There's just one definition, though it's a little tricky. In fact, this whole lesson you might find a little tricky, but we'll kind of like two levels. There'll be the level of, here's the formula, just get through these formulas and learn how to use them and you'll be fine. And then we'll get into the more conceptual level of why it works. But if that proves to be, kind of not of interest or over your head, then you'll be fine just sticking with the formulas. Well, let's take a look. There's just one definition, and it is a geometric mean. When you hear the word mean, you should kind of think of the word average. But all that means is what the mean means is when the means of a proportion are the same number. So if you remember a proportion, you have something like A over B equals C over D. And the means are these two right here. The kind of not the first, not the last, but the in between, the second and third numbers. So when those two numbers are not, in this case, different, but when they are, in fact, say we have, let's just go A over X equals X over B, where again, the bottom of the smaller ratio and the top of or smaller of the first ratio and the top of the second ratio are the same number. This number here, X, would be the geometric mean. Okay, so for example, if we did something like, let's say 4 over 12 and 12 over 36. Okay, that's a true proportion. You can do the cross multiplication and you'll see they work out the same. But where you have the similarity here. Okay, and the way that you can express this in terms of a formula is geometric mean is not only how I wrote it in the proportion, but you could also write it as x squared equals a times b. Okay, so you could see that in the first example, if I were to cross multiply right here, I could do x times x would be x squared, a times b would be ab, and so x squared equals ab. Or again, you can see the same thing with the example of 4 over 12 and 12 over 36. In both of those cases, they reduce to 1/4 or 1/3, but the means are the same number, and that's what we call the geometric mean. One reason we care about this is that we'll be working with these triangles that I have here on the left, where you have a right triangle that is then divided up into two other right triangles, as you can see there. And for example, why this works is if you, hang on, let me just turn the page. Okay, say I wanted to compare this triangle to this triangle, the two little ones inside. And so I've got the triangle up here, and I want to compare the legs of the short leg to the long leg. So I might say h over x equals, and then I want to compare it to these right here. Actually, let me go and do it a different way. Let's do x over h equals, and then I were to compare it to this triangle here, and I would get h over y. Okay, now I've kind of scribbled all over that. Oh, let me redraw that. All right. Okay, where you could see that this represents the larger triangle right here, and this represents the smaller triangle right here. But what those two triangles have in common is they both have h. For the red triangle, h is the shorter side, whereas for the green triangle, h is the longer side. But again, they have this h in common, and so that h in this case would end up being the geometric mean. If I were to try to solve this, I would get h squared equals x times y. And so then that h, just like this x over here, that's what we call the geometric mean. So kind of look at where that's coming from, but the big idea, just go to the basic definition. If you really want to be basic, x squared equals AB. And we'll find some applications here in just a second. So that's our definition, a geometric mean, where the means of a proportion are the same number. And it can be expressed as x squared equals A times B. So let's look at some questions to flesh this out just a little bit for class. So number one is, how many similar triangles are formed by the altitude to the hypotenuse of a right triangle? And so what that's describing is, you can draw a right triangle right here. Oops, let me fix it. Got a right triangle, whoops, let's do it this way. Triangle A, B, C. But if I draw an altitude from D to C here, and so that's also a right triangle. What I actually do create is I create three similar triangles. I have the large one here. I have the medium one here, Mama Bear, and then we have Baby Bear right here. Okay, and all three of those right triangles, A, B, C. The other one would be triangle. If we say A, B, C, then the other one would be C, B, D, and also triangle, because that would be C, B, D, this one. Okay, and then the other one would be A, C, D. Okay, and so then you actually create three congruent right triangles, and you always have to kind of orient them to make sure you're getting the letter order correct. But again, you're always going to have kind of the large one, kind of a medium one, and then a smaller one. Okay, and so the key to this is that it actually allows you to find distances with the triangle very easy using the geometric mean. And that's what we'll get to in a couple questions from now. But for this question, basically you want to be able to recognize the three similar triangles that are created by drawing that altitude. And what I asked is, how many are you going to get? You're going to get three similar triangles. Let me just draw it this way. Okay, three similar triangles. Big, medium, and small. All right. Then here's what number two, that lets us practice the geometric mean a little bit, which again is x squared equals A times B. So it says find the geometric mean of 2 and 8, and then we'll do 4 and 9. Well, again, just treat 2 and 8 as your A and your B. It doesn't really matter which you do. And so you just plug it in like a formula. X squared equals 2 times 8. X squared equals 16. So that means x would be 4. I also will point out that the geometric mean is always they have to be positive. Two positives, I think. Yeah, two positive numbers. Okay, so no -4 is our answer. So the geometric mean here would be 4. Just to put it in the language of the proportion real quick, that would be like if we said 2 to 4 is the same as 4 to 8. Okay, we can see it's kind of the middle number, geometrically speaking, multiplication-wise. That those both reduce to 1/2. But again, your means are the same number. So we can just very quickly do the same thing with 4 and 9. We just do x squared equals 4 times 9. So x squared equals 36. X equals 6. So you can see finding the geometric mean is not that difficult. It's maybe a little more difficult to understand why you're doing it and to apply it to the actual triangles. But again, here 4 to 6 is the same as 6 to 9. That's one way to check to see if you have the right answer. It should fit in there nicely to create equal ratios, 2/3 to 2/3. Okay, so now let's apply this to an actual triangle with the corollaries. 8.12 and 8.13, they're just the geometric mean corollaries. And they combine these two principles, taking a right triangle and dividing it into three similar right triangles, and then the geometric mean. And this is how it works. I'm just going to show you the formulas here, and we'll kind of get into in class why it actually works. But what it does is it allows us to relate all these various distances of the three triangles. So you have A, B, and C. They are the kind of the sides of your larger triangle. Then you have the altitude h, and then x is just this distance here, and y is just the shorter distance here. C always represents the entire hypotenuse of the larger triangle, okay? And so the main corollary basically says that h squared equals x times y. And so there's a direct relationship between those two shorter distances and the altitude. And again, that comes from setting up a proportion in which h is used in both ratios, and it's the geometric mean. But for now, just remember, you want to start memorizing that the altitude squared is equal to the two divided sides multiplied by each other. And then the corollary is the same principle, but getting the other sides involved. One starts with a squared as the geometric mean. And if a is the geometric mean, then you have it's equal to x times c. And the way to remember that is both of these are going to have to do with the legs of the larger triangle. And the a always is related to the x, which is closest to it, and then the entire c. Okay, and then whereas the other corollary is b squared, and b will always correspond to the y, and then the larger side. So b squared is equal to yc. And we're going to use these in number 4, and you're going to be able to see how that the different sides of the divided triangle can be found using the geometric mean. So let's go ahead and solve this and practice this with number 12 on page 512. All right, so what we have to do is we have to solve for the missing variables. And so we want to begin looking at what the values they've given us. Again, we have one large right triangle, and then we have the little one and the larger one right here. And the key to solving these problems is you have to recognize which values you have. Do I have the altitude? If you have the altitude, you're going to be using the h squared equaling x times y. If you have the a side, then you're probably going to be using x and c. If you have the b, you're probably going to be using c and y. So let's go ahead and see what they've given us. We can see that they have given us here the altitude. So that means we're going to be using h. Okay, and we can see, okay, h, x, and y, and I can see that works out nicely because I have 2 of those, and that means I can solve for the third one. So here, let's take a look at this. We have h squared is equal to xy. We can see that our h is 10, so 10 squared is equal to 20x. And now we can just begin to solve that. 100 equals 20x. I'm going to divide by 20, and so then I get 5 equals x. So it's just that simple. We have found the first variable. X equals 5. Now again, the algebra is fairly easy. What's going to confuse you on this is the setup. And that's why as quickly as possible, you want to memorize these corollaries of h squared equals xy, a squared equals xc, and b squared equals yc. Because now that we have both x and this 20 down here, we can now go ahead and solve for z and y. And it's just a matter of picking whichever we'd like to do first. Since y comes first alphabetically, I will go ahead and start with the y. So if we remember, y is equal to, we have, in this case, we'll say y squared is equal to x c, okay? Might be a little confusing there, but that means the closest number and then also the entire distance right here. So the entire side of the length. So we don't know y, that remains our variable, y squared, but that's equal to the closest side, which is 20, times the entire side together. Now, this is where you could get tempted to just put 5, but it's not just 5, it's the entire side. So 20 plus 5. And so that is 25 total here. Make sure we have that right. Yes. Okay, so then we go ahead and multiply that together. 20 times 225, you're going to get y squared equals 500. And then we just need the square root of 500 to give us y. Y equals the square root of 500. Now in class, we're going to go ahead and start learning another technique or simplifying rule of how to simplify radicals, because the square root of 500 is correct. But we need to be able to simplify that. I'm not going to do that in this video yet, but just to give you a heads up, the simplified answer is 10 times the square root of 5. And if you remember how to get that, good. I look forward to you sharing that with the class when we go over this. But square root of 500 is a good start. So that gives us y. Y is now 10 square root 5. And now let's find the last side, which is here with z, which again, z squared is going to be equal to the nearest short side, so that's the 5 side, times, again, the entire length down here. So that's just going to be 5 as the short side. And the entire long side, again, is not 20. Don't do that. It is the 25 is the entire length. It would be your c. So that simplifies to z squared equals 125. And then, so then z is simply the square root of 125. Which in first effort, that's a fine, good answer, but we're going to want to learn to simplify that even more. And so that you'll find out that that is z is equal to 5 root 5. And again, we're going to review that simplifying radical process in class. Okay, so we have similar triangles. And we're going to be using the geometric mean. And again, the real trick is to memorize those corollaries so that when you start to see all these x, y, z's, and all the various numbers, it'll look very confusing. But if you kind of order out the formulas, you'll see the actual solving of the problem is not very difficult. All righty, look forward to discussing this with you in class and helping you in every way possible. Talk to you soon, and see you.